All right, we're ready to start the fifth section of the derivatives chapter. And of all the formulas and rules we've learned up to this point, the chain rule is by far the most important rule when it comes to differentiation. So I would say that your success in this class is dependent upon your mastery of this rule. And if you're going to take Cal 2, knowing this rule will really help you progress and understand the concepts of Cal 2. The way that I like to, the analogy I like to make is that the chain rule is like learning how to walk, and then when you get to Cal 2, you have a new sort of chain rule that you're learning how to walk backwards. So the better you can walk forward, the better you'll be able to walk backwards in Cal 2. All right, so here's the chain rule. Here's what it says. The derivative with respect to x of a function composed with another function, that is the g function, g of x, plugged into the f function, so that's functional composition, is equal to the derivative of f. So you have to take derivative of the f function, then plug g into it, then multiply that times the derivative of the g function. All right, let's go to, sorry about that little skip there. Like I was saying, the derivative of the f function, okay, plug g into that, and then multiply that times the derivative of the g function. Now, this is going to take some going through problems in class for you to really grasp what this is saying. So for now, you've seen the rule. We'll apply it to some examples in class. What we do have, though, is the power rule. Remember the power rule back from our basic differentiation rules? Power rule was right, where was it? Power rule was right here. So it said if we add x to a power, we pull the power out, we subtract 1 from it. And you should all be pretty good at that by now. Now what we're saying is that this is an extension of that power rule, combining it with the chain rule. So it says, let's say that u is some function of x. So this right here, instead of it just being x to the n, we're saying this is some function being raised to the nth power. Then the derivative of this will be first the power rule. So the n comes out, boom. We subtract 1, boom. And then, so it's n, u to the n minus 1. But then we have to multiply that by du dx, which is the derivative of this function up here. So there's a couple of different ways to notate this. U to the n, right? The derivative of u to the n is n, u to the n minus 1 times the derivative of the u, this thing right here, the base. Or you could say, if you have some function f of x raised to the n, so this power is being applied to the whole function, technically I should put that n right here like this. That's the proper notation. So that means not the nth derivative. Take f, raise it to the nth power, then the power comes out n, then again here I should put the power up here just to be technically correct. So we have the n comes out, f to the n minus 1, so that's whatever the f function is, now raise it to the n minus 1, and then times the derivative of whatever the f was, whatever the function f of x is. So again, it's going to take us doing tons of examples for you to understand that, but those are the rules. I bring those to class, make sure you have them sitting next to you so that when we go through this, you'll have something to reference.